This marks a historic moment as humanity embarks on its first ever journey to orbit Mercury, a planet that stands at the forefront of our solar system amidst the vast expanse of celestial bodies. Mercury, though small and seemingly insignificant at first glance, is shrouded in a captivating veil of intrigue and mystery. Recent revelations brought forth by the relentless efforts of NASA have unearthed astonishing secrets about this enigmatic planet, sending shockwaves through the scientific community. It is a testament to curiosity and ingenuity that we have begun to unravel the mysteries of Mercury, a planet often overlooked in favor of its more flamboyant cosmic counterparts like Jupiter and Mars. Nestled closest to the scorching embrace of the Sun, Mercury's diminutive size and blistering speed make it a celestial anomaly deserving of closer inspection. Despite its proximity to Earth, Mercury remains a tantalizing enigma, its secrets veiled by the intense glare of our solar system's central star. The journey to understand Mercury has been long and arduous, stretching back to ancient times when early astronomers cast their gaze upon the heavens. From the first recorded observations in 265 BC to the pioneering efforts of astronomers like Zupus in 1639, humanity's fascination with Mercury has endured through the ages. However, it wasn't until the dawn of the space age in the 1960s that we truly began to unravel the mysteries of this elusive planet. The advent of space exploration, spearheaded by organizations like NASA, has provided us with unprecedented insights into the nature of Mercury. Through the lens of advanced telescopes and space probes, we have beheld the awe-inspiring beauty and complexity of this celestial body, revealing a world teeming with secrets waiting to be uncovered. Yet, the path to understanding Mercury is fraught with challenges. The planet's proximity to the Sun poses formidable obstacles for observation and exploration. Studying Mercury is not for the faint of heart, as the intense heat and gravitational forces unleashed by the Sun make it a hostile environment for spacecraft. Only through meticulous planning and technological innovation have we been able to dispatch missions like Mariner 10 and Messenger to explore the mysteries of Mercury up close. These intrepid spacecraft have braved the perils of space, offering us glimpses into the hidden world of our solar system's innermost planet. The revelations brought forth by these missions have been nothing short of astounding, challenging our preconceived notions of Mercury and its place in the cosmos. From its blistering speed as the fastest orbiting planet in our solar system to the tantalizing possibility of extraterrestrial life lurking beneath its surface, Mercury continues to captivate and confound scientists and stargazers alike. As we stand on the precipice of a new era of exploration fueled by the promise of discovery and the thirst for knowledge, the scientific community is poised to unveil Mercury's darkest secrets once and for all. Through the lens of cutting-edge technology and the collective efforts of researchers around the globe, we are on the brink of unlocking the mysteries of this enigmatic planet and ushering in a new era of understanding in our exploration of the cosmos. Join us on this journey of discovery as we delve deeper into the secrets of Mercury and unlock the mysteries of our mysterious galactic neighbor. Both of these missions were the brainchild of NASA, and they are the primary sources of nearly all the information we have about Mercury today. For one, the Mariner 10 spacecraft conducted 3 flybys, each unmasking the cracked-up, crater-ridden surface of Mercury and shedding light on its magnetic field. Equipped with 2 telescopes, spectrometers, a magnetometer, and a plasma analyzer, Mariner 10 was intended to glean as much data as possible from its visit to Mercury. The probe slowly found its way to the small, fast planet after using gravity assistance from Venus. As Mariner approached Mercury, scientists were amazed to see the chaotic surface with lots of craters and ridges, much like our moon. The images from Mariner were mind-blowing, as Mercury turned out to be nothing like what experts had anticipated. Aside from the rugged planetary surface, the spacecraft also detected a weak magnetic field and an unusually large core. Mariner 10 took over 2,700 images of Mercury, giving scientists a rare and unparalleled view of the fascinating landscape. The second flyby of Mariner 10 was on September 21, 1974, during which it captured the southern polar region of the sensational planet. The last flyby of Mariner 10 was in March 1975, after which it stopped transmitting signals to Earth. Later investigations revealed that the spacecraft had exhausted its gas supply and was unable to make any more rounds. The magnificent work of Mariner 10 was continued 30 years later when NASA's Messenger took off to the not-distant planet. Unlike its predecessor, Messenger didn't just conduct a flyby but also managed to orbit the planet. Thanks to this, scientists were able to gather more in-depth and interesting data about the planet. Armed with the interesting pictures of Mercury, NASA sought deeper data with this mission. This time, it wasn't just about pictures. The agency wanted to know more about the atmospheric conditions, chemical composition, and magnetic field of the planet. NASA also had to study the planet's geological history and planetary core. Interestingly, the probe made 3 orbits around Mercury, during which time it took about 200,000 photos of the planet. These pictures were unique because, unlike the Mariner mission, they featured both sides of the planet. During the Messenger mission, the probe managed to enter well into the planet's orbit, hovering at about 215,000 kilometers above the planet's surface. This proximity enabled the probe to take pictures of both the light and dark sides of Mercury. After digging deep into the images and comparing them with data from the spacecraft's instruments, NASA found out that our dear sister planet had unusually high concentrations of calcium and magnesium on its night side. Moreover, the magnetic field of the planet seems to be weirdly distorted, appearing stronger and more intense in the northern regions. This weird pattern of the magnetic field puzzled scientists for years until deep research analysis was conducted to reveal the secret behind this anomaly. When the secrets were finally revealed, it sent shockwaves throughout the scientific community. You see, Mercury's weird and unusual magnetic field is all due to how the planet formed at its core. Magnetic fields on planets are generated from the interactions that occur in their core. Take Earth as an example. The innermost parts of Earth's core contain liquid iron, but towards the outer core, this iron changes to solid. The continuous solidification of liquid iron in the core is what causes the magnetic field. In other words, more and more solid iron is formed in our planet's core every day. As liquid iron cools and crystallizes to form solid iron, it interacts with the surrounding liquid iron. As this happens, as the Earth spins around its axis, a form of convective current is created. Mercury, the smallest and innermost planet in our solar system, remains a source of fascination and intrigue for scientists and space explorers alike. With its proximity to the Sun and its unique characteristics, Mercury presents a host of challenges and mysteries that have captivated researchers for decades. One of the most striking features of Mercury is its extreme temperatures. Due to its lack of a substantial atmosphere to retain heat, Mercury experiences dramatic temperature fluctuations. During its day, which lasts approximately 176 Earth days, twice as long as its year, surface temperatures can soar to over 430 degrees Celsius, 800 degrees Fahrenheit. This scorching heat is due to Mercury's proximity to the Sun, where it receives intense solar radiation. Conversely, on the night side of the planet, temperatures plummet to around -170 degrees Celsius, -280 degrees Fahrenheit, as there is no atmosphere to trap heat. These stark temperature differentials make Mercury one of the most thermally contrasting bodies in our solar system. The lack of a significant atmosphere on Mercury is another intriguing aspect. Unlike Earth, which has a dense atmosphere that moderates temperature extremes and supports life, Mercury's exosphere is incredibly thin, composed mainly of atoms blasted off its surface by solar winds and meteoroid impacts. Mercury's exosphere consists mostly of oxygen, sodium, hydrogen, helium, and potassium. This sparse atmosphere offers little protection from the Sun's radiation and cosmic rays, contributing to Mercury's harsh and inhospitable environment. Despite these challenges, Mercury holds clues to understanding the early history of our solar system. Its surface is marked by a multitude of impact craters, similar to the Moon, indicating a history of intense bombardment during the solar system's formation. These craters range in size and shape, from small bowl-shaped depressions to larger basins hundreds of kilometers across. The largest crater on Mercury, known as the Caloris Basin, is approximately 1,550 kilometers, 960 miles, in diameter, and was formed by a massive impact billions of years ago. In addition to impact craters, Mercury's surface features include scarps, ridges, and volcanic plains. One of the most notable geological features is the widespread presence of lobate scarps, cliffs that extend for hundreds of kilometers and rise up to several kilometers high. These scarps are thought to have formed as Mercury's interior cooled and contracted, causing the planet's crust to buckle and fracture. Volcanic activity has also played a role in shaping Mercury's surface. Smooth plains composed of volcanic basalt can be found surrounding some of the larger impact basins. These volcanic deposits suggest that Mercury was volcanically active early in its history, releasing molten rock onto its surface. The presence of volcanic features provides insights into Mercury's geologic evolution and the processes that shaped its rugged terrain. Mercury's magnetic field is another area of scientific interest and mystery. Unlike Earth's global magnetic field generated by a dynamo process in its liquid outer core, Mercury has a unique magnetic field. It is much weaker than Earth's magnetic field and is believed to be generated by a dynamo process in its partially molten outer core. However, Mercury's magnetic field is offset from its center and has a higher intensity in the northern hemisphere than the southern hemisphere, a phenomenon that scientists are still working to understand. The origin and evolution of Mercury's magnetic field are closely linked to its interior structure. Mercury is composed primarily of silicate rock and has a large iron-rich core, accounting for about 60% of its mass. This dense metallic core is thought to have formed early in Mercury's history, when denser materials sank to its center during the solar system's formation. The interaction between the liquid outer core and the solid inner core generates Mercury's magnetic field, which has been observed and studied by spacecraft missions like Mariner 10 and Messenger. NASA's Mariner 10 mission, launched in 1973, provided the first close-up images and scientific data of Mercury during 3 flybys in 1974 and 1975. Mariner 10 captured detailed images of Mercury's surface, revealing its cratered terrain and volcanic plains. The spacecraft also detected Mercury's magnetic field and provided valuable insights into the planet's composition and geology. 3 decades later, NASA's Messenger mission, Mercury surface, space environment, geochemistry, and ranging, expanded our understanding of Mercury with unprecedented detail. Launched in 2004, Messenger became the first spacecraft to orbit Mercury, allowing it to map the planet's surface and study its composition, magnetic field, and geologic features. Messenger's observations confirmed the presence of water ice in permanently shadowed craters at Mercury's poles, despite the planet's proximity to the Sun. The discovery of water ice on Mercury was a surprising finding that raised questions about its origin and stability. Scientists hypothesized that water ice could have been delivered to Mercury by comets or asteroids, which impacted the planet's surface and deposited volatile materials in cold, permanently shadowed regions. The presence of water ice on Mercury challenges previous assumptions about the distribution of volatile compounds in the inner solar system and provides clues to understanding the planet's history and potential habitability. Future missions to Mercury, such as the European Space Agency's BepiColombo mission, aim to build on the discoveries of Mariner 10 and Messenger. BepiColombo, launched in 2018, is a joint mission with Japan Aerospace Exploration Agency, JAXA, designed to study Mercury's surface, magnetosphere, and interior structure with advanced instruments and technology. The mission includes 2 orbiters, Mercury Planetary Orbiter, MPO, and Mercury Magnetospheric Orbiter, MMO, together providing a comprehensive investigation of Mercury's environment and evolution. BepiColombo's scientific objectives include mapping Mercury's magnetic field in detail, studying its surface composition and geological features, and investigating the planet's exosphere and interactions with solar wind. By combining data from multiple instruments and perspectives, BepiColombo aims to uncover new insights into Mercury's formation, evolution, and ongoing processes. In addition to studying Mercury's surface and geology, scientists are interested in its gravitational field and orbital dynamics. Mercury's orbit around the Sun is highly elliptical, with a period of 88 Earth days. Its eccentric orbit causes significant variations in its orbital speed and distance from the Sun, leading to gravitational interactions that have shaped its orbital dynamics over billions of years. Understanding Mercury's orbital dynamics is crucial for broader questions about planetary formation and evolution in our solar system. The gravitational interactions between Mercury and other planets, particularly Venus and Earth, have influenced its orbit and could provide insights into the early dynamics of the solar system. Studying Mercury's gravitational field and orbital characteristics helps scientists refine models of planetary migration and stability in the inner solar system. The study of Mercury also contributes to our understanding of exoplanets, planets orbiting other stars beyond our solar system. Many exoplanets discovered to date exhibit characteristics similar to Mercury, such as close proximity to their parent stars and extreme temperatures. By studying Mercury as a representative of terrestrial planets in hot, hostile environments, scientists can infer the diversity of planetary systems and the potential for habitability beyond our solar system. Mercury's role in the solar system extends beyond its scientific value to its cultural and historical significance. Ancient civilizations observed Mercury's movements in the sky and incorporated them into their mythologies and calendars. The name Mercury derives from the Roman god of commerce, travel, and communication, reflecting the planet's swift movement across the sky. In conclusion, Mercury continues to captivate scientists with its unique characteristics and challenges. From its extreme temperatures and thin atmosphere to its cratered surface and mysterious magnetic field, Mercury offers valuable insights into planetary formation, evolution, and dynamics. Future missions like Bepi Colombo will further unravel the mysteries of Mercury and pave the way for new discoveries in planetary science and exploration.